Hello, welcome back. In this video, let us learn about the join functions in dplyr package in R. It is rare that a data analysis requires only a single data frame or data table. Typically, you may have many data tables or data frames and you must join them together to get the desired answers. Let us jump into R quickly and learn about the join functions. Before we start about the join functions in R, let us have a quick theoretical understanding about various types of joins. Let me go through this link. Here it is showing various types of joins, mainly mutating joins and filtering joins. In mutating joins, there are four types of variations: left join, right join, inner join and full join. In the filtering joins, there are two types of filtering joins: semi-join and anti-join. In the left join, all the records from the left table and corresponding matching records from the right table will be shown. In the right join, all the records from the right table and corresponding matching records from the left table will be shown. In the inner join, only matching records from the both tables will be shown. In the full join, it will be shown all the records from the both tables. In the filtering joins, it matches the records from the another table and shows only the record from the first table. It won't add any new columns to the first table. In anti-joins, it shows only the non-matching records from the other table. Here, there won't be any additional fields. Now let us go back to the practical examples of join functions. Let us start with the basic syntax of the left join. In the left join, within brackets, we have to give the first table, second table, and the key fields on which these both tables will be joined, and if there are any common fields in the both tables, we can give a suffix for those fields. And when we are joining, by default, the key fields will be shown only from the one table. If we want to retain the key fields from the both tables, we can use this option keep. Now let us import some sample data. For that, we require to import these two packages, data table and dplyr. And let me change the source path or working directory and import all the sample data. To execute any command, we have to enter Ctrl plus enter. Let us go through each sample data. This is an invoice data having invoice date, invoice number, product code, employee ID and amount. The employee master will have this employee ID and some additional information about the employees. Let us see. This employee ID and some additional data about those employees. Same way, in product master, product code is there and some information about those products. In the range master, we can use this master for categorization of the rows. And here there are some other variations of the masters. Here I have intentionally taken some duplicates in the key field, and this table we have to merge based on the multiple fields. Here we have multiple keys, and in this table the field names are different. Let us go through how we can do matching of the two tables in R. First, we will start with the mutating joins. The mutating joins, new fields will be added to the first table. I will start with the left join. Whatever we are showing in this left join example, all the variations can be applied in the subsequent joins also. Let us start with the basic example. The left join, I am just giving the left table and right table. Let me execute this by pressing Ctrl Enter. Here, the R language automatically identifying the key fields from both the tables and joining accordingly. Let me see the output of this table. It is joining based on the employee ID and corresponding employee data has been merged with this table. If there are any non-matching records, it is showing all the records from the left join and corresponding right table data will be shown as NA values. It means null values. The same output can be derived by changing some options. In this example, we are entering the key field by using the by operator. By equals to, within quotations, we have to give the key field name. Let me execute this and see the output. It is same. Instead of by, we can also use the function called join by. In join by, within quotations, we have to enter the key field name in the quotations. Let me see the output. It is exactly same. Even we can enter the field name without quotations when we are using the join by function. Let me see this. By removing the quotations, let's execute this command. It is same. Now I am keeping key fields from the both tables in the output. For that, we are using the keep equals to true option. I'm just cutting this and pasting here, and I'm changing the table name here. Let us observe the output from this. Here I'm just adding keep equals to true. Let us see the output. In this output, the key field has been shown from the both tables. However, it is suffixing by the .x and .y. Here, if any common field name is there from the both tables, it will automatically assign the .x and .y as suffix. We can change the suffix by giving the options here. Suffix equals to small c within brackets. For the left side table, what should be the suffix, and right side table, what should be the suffix. We have to give the input here. Let me execute this and show the output. In the left side key table, in the left side it is showing underscore left, in the right side it is showing underscore right. Till now, whatever we have seen these variations can be applied in all these functions: right join, full join, and inner join. And some options can be applied for filtering joins also. Now let us try executing the right join and see the output. In this example, it is showing all the records from the right table, and wherever there is no matching from the first table, it is showing NAs. It means null values. In the full join, let me execute this full join and see the output. It is showing all the records from the left table and on the right table, and wherever no matching is there, it is showing the null values from the both left table and the right table. In the inner join, it shows only the matching records from the both tables. Let me see the output. It is showing only the matching records. Now, let us move into filtering joins. Please observe the output carefully and find out the difference between this inner join and semi join. Let me execute this semi join and see the output. In both places, same number of records only showing. However, in inner join, all the fields from the both tables will be shown. In semi join, only the columns from the first table has been shown. Now let us see the anti join. In anti join, it shows only the non-matching records, and the columns from the first table only will be shown. Let me see the output of this table. It is showing only the non-matching records. Now let us try with some variations. Now I am adding the product master to the invoice data. Join by product code equals to product series. Let me execute this. I am getting some error. Let us see what it is. Here we need to use the double equals to instead of single equals to. And let me execute this one by putting double equal to symbol. Now it has been executed. Let me see the output. In this example, since the key names are different from both tables, we have to give left side key field and right side key field in this join by function. Instead of using join by, we can also use the by equals to small c within brackets. We can give the left side key field name and right side key field name. But whenever we are using the by operator, we have to use double quotes. Otherwise, we will get the error. Let me execute this and see the output. In this, the output is same for both. In the next scenario, we have different key header names and duplicates also exist. For that, I am using the product master which has duplicates. Let me execute this function and see the output. If we observe that in the left table, we have 10 records. Due to these duplicates, we are getting 12 records. There are 2 duplicates. In the next example, let us try matching with multiple key fields from the both tables. In the first scenario, I am just giving. In this example, the field names are same in the both tables. Let me execute this and see the output here. It is joining based on the 2 fields, product code and employee ID, and the corresponding output has been mapped with the left table. Now let us try with multiple key fields and different header names in the both tables. In the earlier example, we have given only one condition. Now we can have multiple conditions separated by a comma. Let me execute this, and the output is it is joining based on the product code and employee ID, and the column names are different from both tables. Now let us see a Cartesian product or cross join. In cross join, it generates all the combinations from the both tables and stores all the combinations into this table. Let me execute this. Whenever we are doing cross join, the number of records in the output will be a multiplication of number of rows in the first table and number of rows in the second table. Let us observe this. Number of rows in the first table are 10 and the same from second table is 7. Now let us see the number of rows from the output table. It is 70. 10 into 7, 70. And finally, let me explain a special type of merging or joining. It's called range lookup. In Excel, we used to do the range lookup. The same can be repeated here in R also. For that, we are using a function called closest. Just go through the syntax. Left join, first table and second table, join by. In this, we have to use the closest. If we put the greater than symbol, it retrieves the nearest matching number above this range. If we put less than, from the master, it will take the below number than this invoice number. Let me execute this and see the output. Based on this invoice number, it is showing the range as per our master. Our master includes range and description. The difference between Excel range lookup and R range lookup is, in Excel, we have to set the data in ascending order. But here in R, it takes care of that. No need to have in sorting order. After joining the table, if we want to remove this range, we can do so by this command range : equals to null. Let me execute this and see the output that range has been deleted. As you have seen, there are multiple join functions and variations. Each function has its own purpose and choosing the right one depends on your specific data requirement. Experiment with all these things and master the art of joining datasets in R. Thank you for watching this video and stay tuned for more valuable content.